In this lesson we're going to look at slope graphs. Before we do, however, we need to have a quick look back at some of the properties of slopes that we need to understand for this lesson. I've drawn some lines here and I want you to think about the slopes of these for a minute. For example, in this first one, the slope is the rise over the run. And here we can see that if we run across 1, we rise up 1. So therefore the slope is 1. In the second one, which is a bit steeper, we run across 1 and we rise up 2. That's why the slope is 2. And so on. So you'll see the steeper the lines get, the higher the slope is. The more positive the slope is. Then we come to the other extreme where the line is flat, like here, and which means there is no slope at all. And as you'd expect, the slope is therefore 0. Then when the line starts leaning backwards, the rise over the run becomes minus, because we're running backwards as opposed to running forwards. So if you run back 1 here, you rise up 1. Therefore the slope rise over run is minus 1. And minus 3 here and minus 4 here. So as a quick summary, every time the line leads forwards, if it leans forwards, the slope is plus. If it's flat, the slope is 0. If it leans backwards, the slope is minus. Or you could say the slope is increasing as you go right to left. Let's see how we use this in graphs. On this graph I've drawn down here, you can see that the tangent, well, first of all I've drawn a cubic function. And if you take the tangent at each point along the function here, we can now generalize about the slope. For example, we know the slope of this, because it's leaning forward, is going to be plus. The slope here, because it's flat, is going to be 0. And the slope here, because it's leaning backwards, is going to be minus. Now we start again with a cubic function here. We call the function fx. And what I'm going to do is I'm going to draw another graph. So we have the fx graph, but underneath it, directly underneath, I'm going to draw the graph of f dash x. What that means is, if you can imagine, at every point along fx here, if I draw a tangent and get the slope, and then plot that slope down here, what would that graph look like? And we start by getting, I suppose, the easiest points, certainly this one up here. So at the top, if you drew a tangent through that point, we can see from our previous analysis that's going to be a slope. That's going to have a slope of 0. So on the slope graph, the value of the slope is 0 at that point. So down here, we have the first point on our slope graph. For the same reason, if I take the minimum point, at that point again, if you can visualize the tangent going through that point, it's going to be a slope of 0. So the slope is 0 at that point. So on the slope graph, we have a value of 0 there. So we have the first 2 points on our slope graph f dash x. Now from the previous analysis, what we've just been talking about, all along here before that point, the slopes of the tangents, well, the tangents are going to be leaning forwards all along here, so their slopes are going to be positive. Which means on the slope graph, before that point, all our values will be in the positive area here, above the x-axis. We don't know where exactly, but we do know it'll be somewhere up around there. For the same reason, between the max here and the min down here, the tangents are leaning backwards, so the slopes will be negative. So on the slope graph, our values will be minus, which means they're somewhere in this region. And finally, once you go above this minimum point here, if you can visualize again the tangents all along here at every point, their slopes are plus. Their slopes are plus, so if you graph the slopes, they're all plus values, so they'll be in the plus area of the slope graph down here. So they'll be in around there. If you put all that together, a clear shape emerges. If you put all of our points together here, so it clearly looks like a quadratic or a U shape. So let's put in that. So we're going to get a quadratic function here. So there we have drawn our first slope graph. So the first graph is fx, which is a cubic. The second graph is f dash x, which is a quadratic, as you might expect, because slope is dy dx, and when you differentiate a cubic you get a quadratic. We can take this to the next step, and we can now take our quadratic and get the slope again, the slope function of that. So we're kind of getting the slope function of the slope function, as it were, which translates to f double dash x, or d2y dx squared. And it's exactly the same logic as before. If you take the f dash x graph, and you see there the minimum point is around here someplace, so at that point there will be, if you drew the tangent, it would be flat, it would be a slope of 0. So the slope of that, if you drew a slope graph for f dash x, you would expect a 0. You would expect a 0 right below that. Also, before that point, if you imagine all the slopes of all the tangents along here, they're all leading backwards, so they're all minus. So before that point on the slope graph, all the slopes are minus, so we're in the minus area. We're down here. Also, if you imagine the slopes of all the tangents along here, they're going to be plus. So you'd expect that if the slopes are plus in the slope graph, they're in the plus area beyond that point. So they're up around here. The overall picture that emerges here, if you look at the overall pattern, we've got a negative, and we've got a 0 point, and we've got positive. So the overall picture that emerges is a straight line. So we can now draw that also. And there we finally have it. If you look at the three graphs together, if you differentiate a cubic, you get a quadratic. If you differentiate a quadratic, you get a linear. And or another way of saying it is the slope graph of a quadratic is the slope graph of a cubic is a quadratic graph, and the slope graph of a quadratic graph is linear.